Okay, so good afternoon, everybody. So let me quickly tell you what we did so far in chapter 4. Let me hide this one. Okay, so what I told you guys, we have something we call interrupts, and I told you this is something very wonderful. It's very great. Why? Because without interrupts we cannot make a big programs or real applications. Why? Because as I told you now, your program should have the main program. Also, you have interrupts, right? So far, I only explained to two sources of interrupts, RTI and IRQ, but we have more sources, okay? And now, because of interrupts, I can run multiple tasks at the same time, okay? So, for example, if your program has several tasks, I can put one task here in the main program. I can put another task here, another task here, another task here, and so on, right? Eh, you are gonna feel like you are running all the tasks at the same time, but that's not true, right? Why? Because actually, when there is an interrupt, you leave task one and go execute task two and then come back, right? Same thing, if there is interrupt from IRQ, you leave this one and come back. So at any time, we only execute one task at any time, right? But again, because the computer is very fast or the microcontroller is very fast, you are going to feel like you are running several things at the same time, right? And also, you can notice several programs I taught in chapter 3. In chapter 3, I put them here in the main program, right? So in chapter 4, I repeat the same programs again, but I put them in interrupts. Yes, that's true. So you can do the same thing. You can put it in the main, you can put in RTI, you can put in IRQ. This is when you design your program. If I give you several tasks, you need to decide, okay, where you have to put each task. Okay. So now your program is not going to be written in one place anymore. The main program has some code. Every interrupt source should have some code. Okay. Very important. I have to repeat it because I know some students are confused. Okay. For interrupts, guys, we don't write instruction to call interrupts, right? So someone, usually students ask me, okay, so this is my code. So tell me which instruction here is going to be used to call interrupt. No, we don't write. This is, although interrupt looks like a subroutine, but big difference, right? Because the main difference is in subroutine, you have to write an instruction to call the subroutine, right? But for interrupts, they are called automatically when an event happens. So there should be some hardware event. Okay, so that's what I explained. Also, I explained to you last time we have two sources of interrupts. One is called RTI, and this is like a timer. Okay, so you have inside the microcontroller, and this is the microprocessor. You have something like a very simple timer. In chapter 5, hopefully I can start it today or at least next lecture. In chapter 5, I'm going to explain a more complicated timer system, but this is like a small timer or simple timer. In this timer, once you set the time, okay, after that, you are going to have periodic interrupts every time out. So for example, I can say, please make interrupt every 10 milliseconds. That means every 10 milliseconds, there is one interrupt, as I explained before. This is RTI, right? IRQ is different. IRQ, as I said, is different. In IRQ, we have external pin, right? And this external pin is connected to something, right? It's like connected to a sensor, connected to a switch, whatever a device, right? Whatever is connected here. But once there is a falling edge here, right, you actually trigger interrupt. So very simple. When I can think I should use RTI, very simple. You use RTI, guys, if you want to do periodic action, like flashing LED. So in flashing LED, I want to turn LED on for 1 second, off for 1 second, right? But IRQ is used if you want to every time there is a falling edge, I'm going to execute a subroutine, right? So this is the event. So IRQ is used if you want to execute a subroutine just in case there is a certain event. Like for example, I pressed a button. So it says this can be an event. There may be another event. Okay. For example, you have here a sensor, and you have another sensor here is infrared transmission light. So this is infrared light, and this is a receiver. Okay. And every time someone enter a store, or someone cut the light here, you actually generate like a pulse here. This pulse is going to trigger interrupt. In this case, I use IRQ interrupt to count. I want to count the number of events, all right? How many times this event has happened, okay? Anyway, so and last time I give you some programs, how can we use both RTI and IRQ? I'm gonna continue on this. I still have like 3 or 4 more programs. After that, I think there is a very little thing in chapter 3. I will go and finish it. And after that, I'm already done with, I'm gonna go chapter 5 if we have time, okay? Anyway, so here, I think I stopped here last time. Yes. So here, look here, guys, what I want to do here. What I want to do is, okay, write a program to count from 00 to 99, right? On the 7th segment, and displays increment the count every time IRQ is interrupted, okay? And the source of this interrupts can come from a sensor to count the number of events, like cars. This is exactly what I was teaching right now. So you have, let me change the color here to red. So what I'm saying, you have like a sensor, right? This way, okay? Every time something best here, this something can be a car, can be a customer, it can be boxes, okay? Something you need to count some events, right? So every time there is someone or something cut the line here, you trigger interrupt, right? So I need to count, right? So how can we do that? I'm going to do it using IRQ, right? So let's look at the problem here. How many tasks, think about it. How many tasks do you have here in this problem, right? In this problem, actually, I have 2 tasks, okay? Not one. One task is IRQ should count the number of events, right? Also, because you are going to display more than 1 digit, here, you need time multiplexing, right? So I need 2 things, time multiplexing. So what I'm going to do right now, guys, I'm going to use RTI to do time multiplexing, right? And then I'm going to use IRQ to do counting, to count. Is that okay? That means the main program is free. Okay, that's true. Yeah. For this program, it's just a simple program. I'm not going to put anything in the main program, but later you can, if you have a keypad, you have LCD, something like that. So here I don't need to use them. That's why if you look here, guys, this is the main program here, right? So the main program, after you come here, you are going to keep looping here, right? Because it's just a simple program, and I have 2 tasks. One task in IRQ and another task in RTI. And all the time, every time there is interrupt, I'm going to go and come back. There is interrupt, I'm going to go and then come back. So all the time I will be here, right? Again, if you want to complicate the program, if you want to add something else, another test, you have the main program is free. So you can write it here. And also every time I'm going to go and IRQ or RTI and come back. Is that okay? Any questions? Okay. So now, let's see how we're gonna do this program. Okay, guys, let's see. So here, number 1, I have to have this table. This is the code. I should have this one, guys. This is the code for the numbers, right? So in case if I want to display number 0, right? So I have to go to the location pointed by the first address plus 0, right? This is gonna give you the code, the 7 segment code, right? If I want to display number 7, so I have to add 7 plus the beginning address. So this is 0, 1, 2, 3, 4, 5, 6, 7, right? So this is for number 7 and so on, okay? So now I have to make a table of the 7 segment codes, right? And every time you want to display a digit, all what you have to do, you have to go to the location beginning address plus the number, right? If it is 9, you will come here, right? So this is one thing we have to do. Another thing also, guys, because here I'm using 7 segment 2, right? So as you know, there should be enable, right? So at I'm gonna use, as I told you, I'm gonna use RTI for time multiplexing. So what I'm gonna do right now, guys, is in one interrupt, I'm gonna enable this one, right? And output a number. Next interrupt, I'm gonna enable this one and output a number, right? Next interrupt, I'm gonna come here again. Next interrupt here. So in every one interrupt, I have to alternate between them, right? Every one interrupt, I have to work on one of them. So how can you do that? I'm gonna tell you how can I do that. Okay, very simple. The way I'm gonna do it, guys. So this is the enable. This is what I have to send to port P, right? To enable one segment, one 7 segment, right? So the way I'm gonna do it, guys, is here I have a variable, I call it count. Okay, so this count should help me. I'm gonna tell you how. So if you have interrupt, here I'm talking about RTI interrupt. So in RTI interrupt, count is equal to 0. So I'm gonna add 0 plus the beginning address here. So I'm gonna take this one, send to port B. Okay, and then I'm gonna increment count to 1. So after 0, now it is 1. So in next interrupt, right? So now count is 1, right? So I'm gonna add count, which is 1, to the beginning address. Now I have this one. I'm gonna send to port P. Okay. Now I'm gonna add 1 to count. So now count is 2, right? So now if count is 2, I have to make it 0 again, because count, this is how it works. So count all the time in one interrupt, count is 0. Next interrupt, count is 1. Next interrupt, count is 0. Next interrupt, count is 1. It's true. I have to continue this way. This is because in one interrupt, I have to take this one, send to port P. Next interrupt, I have to take this one. So how can you do that? I have to add 0 plus the beginning address, or I have to add 1 plus beginning address. That's exactly what I'm. So in one interrupt, I add 0. In another interrupt, I add 1. So how can I do it? Using count here. Is that clear, guys? Any question? Okay. You will see now the program, but let me give you the big picture first. Also, because I have 2 digits here, guys, the 2 digits are stored here in these 2 memory location. Digits, it has 2 memory location, 2 bytes, right? So 1 digit is going to be stored in the first location. The other digit is going to be stored in the second location. So I have 2 memory locations. And again, all what I have to do, guys, so this one, it should have 2 locations, 2 memory locations. Okay. So in one interrupt, I have to take 1 digit, right? And then, as I told you, after I get this digit, I have to convert it to a code, right? And then send it to port B. In next interrupt, I have to take the second one. So one interrupt, I'm going to get 1 digit. Next interrupt, I'm going to get the second one. Again, how can you do that? Count. Still, I can use count. You know why? Because, as I told you, count can be 0, 1, 0, 1, 0, 1, 0, 1. I'm gonna force count to be after to be this pattern 0, 1, 0, 1, right? Because in one interrupt I want to get the first digit. That's why I'm gonna add 0 plus the beginning address, right? In next interrupt I have to add 1 so that I'm gonna get the beginning address plus 1 and so on. Is that okay, guys? Anyway, I'm going to choose a program. I just give you the big picture for now, but let now explain the program. First of all, as you know, I have to put two orgs now because I'm using one for RTI and one for IRQ. We always do that, right? This is one thing. Another thing is we should, and now our program start from here as usual. This is just a configuration for LEDs. You disable LEDs, you enable 7 segment and so on. Nothing is new here, right? Here, port H, I have to configure port H as output. Someone can ask me why port H? We don't have port H here. Okay, that is because here I don't have a sensor, right? To generate pulses to put it in IRQ. So the way I did it is here, this is IRQ, right? I have this push button in port H, as I explained to before, right? So every time I press this push button, so you actually port H, for example, BH0, you are going to generate a pulse, something like that, right? So I have to connect external wire, right? This way. so that every time I press a button, I generate a pulse to trigger interrupt. Okay, to simulate the this pulse here. So instead of having a sensor, I'm gonna press a button. You will see right now in the video, right? So that's why here I have port H. And now this is, you have to enable IRQ interrupt. Also here, let me clear this one here. Also, this is for RTI. You have to enable RTI interrupts, and this is for the timeout, right? Be careful here, because most of the time we are using 7F. Most of the time we use 7F to generate 131 millisecond, right? If you forget and you write here 7F, you will see flicker. You will see flicker. It's because you make interrupt every 131. Sorry. Because you make interrupts every 131, which is very long time, right? That's why. So you turn you turn one segment on, right? Okay, sorry, let me see what's happening here. So you turn one segment on, right? And then the second one after 131 millisecond, which is long time, as I explained last time, right? That's why if you see flickers, that means you have a problem in the interrupt rate of RTI, right? So the way you are gonna do it is, the way you are gonna do it, I'm gonna put number 10. Because number 10, I think it's gonna, if you go to the table, see what's number 10 is gonna give you, but it's gonna give you a very small time for sure. I think number 10, we said here, this is N, right? N and M, right? So if it is 10 means 1000, right? I'm sorry, 000, and then 100, right? This is 10. So if you go to the table here and see what is the value here for N, so N has to be 000, and then this one. So I'm going to take this one, right? So again, which is 0.128 millisecond. Maybe this is too fast. I'm not, if you think it is too fast, I think it worked. It was okay. But anyway, if you think it's too fast, you can select other time here, right? I think it was not dim. It was okay, I guess. Anyway, but you can select any other time if you want. That's okay. But anyway, it should not be long. This is what I want to say. So because most of the time I want to make a delay for 1 second, I take like a long delays, something like that. If it is long, you will see flicker. You got what I'm saying? Anyway, so again, once you see flicker, you should learn that something is wrong in your interrupt timeout, right? Anyway, so this is the main program, as I told you. Now I'm going to show you what should we write in IRQ. So that's what I did here in IRQ, guys. Actually, I did IRQ in 2 different ways. So let me explain the first way first, and then I'm going to talk about the second one. Okay. So what IRQ has to do, right? All what IRQ has to do, guys, every time there is interrupt, I have to increment a count. So because I'm counting, right? Also, if this count is more than 99, I have to make it 00, because that's what I asked you to do. After 99, make it 00, right? Also, you have to convert, because now you have a binary number. You have to convert this number to two digit, and you have to store the digits here, as you see here. So you have to store the digits here. Is that okay, guys? So you should store the digits here, so that RTI is gonna read these two digits and display them on 7th segment. Oh, no, wait a second. Explain it again. Okay, I'm going to explain it again. Look here, guys. But let me see if I can clear. Yes. I think, let me. My breasts I have to keep. So I'm going to explain it again how it works, guys. It's very simple. I'm going to tell you how. So now, what I'm saying, guys, is we have here 2 memory locations, right? 2 memory locations, one location and another location. Is that okay? Number 1, who Who should, and this location should be the two numbers I have to display. For example, if they are 17, so they should be 1 and 7, right? So these two locations should have the two digit I have to display on the 7 segment. First question, who's gonna update these numbers? IRQ, right? So every time there is an event, if it is 17 right now, and there is an IRQ interrupt, it should be 18, right? Another IRQ interrupt should be 19. So who's gonna update these two memory location? IRQ, right? Because IRQ is doing counting. Counting is done by IRQ. Number two, who's gonna read these two values to display them on the 7 segment? Who's gonna do that? RTI. So RTI is gonna read these two memory location and display them on the 7 segment here, 7 segment. Is that okay? But again, as I told you, you have to convert this number to 7 segment code. That's why you have this table here, right? If it is 1, I'm gonna add 1. This is 1. This is, if you add 0, you get this one, right? So I'm gonna have to get the beginning address and add this number here. If it's 7, so beginning address plus 7, you will come to this code. And that's what you have to send to port B. Is that okay, guys? So now let me explain how IRQ is gonna update every time there is one interrupt, one event. It has to increment these digits. I'm gonna tell you how. So this is the way. This is one way to do it. Every time there is an interrupt, guys. Okay. Number one, you have to increment memory location. I call it number. So this number should have from 0 to 99, but in binary. It's a binary. It's a byte. So this byte actually can store from 0 to 255. But I'm not going to allow it to go to 255. Once it's 100, after once it's 100, I'm going to make it 0. Right? You will see right now. So number one, every time this interrupt subroutine is interrupted, we are going to increment the number. Okay, what else you have to do now? I have to check if it is 100. I have to make it 00. That's what I'm doing here. Look here, guys. Now I'm gonna take a number, store it in B. I'm gonna compare it to 99. If it is lower than 99, I'm okay. Just to go to the conversion. If not, come here and clear, because after 99 should be 00, right? Anyway, but still the number is binary. Still this number is binary. Okay, so now here I have to convert this number from binary to decimal and then store. So for example, if this number, for example, is 17, so I have to extract 1 and 7, as I explained before. You have to do a binary to decimal conversion, and then after I get these two digits, I have to store them in these two locations. Is that okay, guys? Yes. So number one, I have to extract from the binary number, right? So I have to extract these two digits. I have to put them here in these two memory locations. Okay. That's what I did. To do that, as I explained before, you have to divide by 10, right? But here, because this number, it has only 2 digits, it's enough to divide only one time by 10. You know why? Because, for example, if it is 72, for example, if I divide by 10, the quotient should be 7 and the remainder should be 2. So I already got 7 and 2, right? Because it's only 2 digits. So it's enough to divide only one time by 10. That's what I did. Look here, guys. So what I did here, I put the number, because you know this division, you have to divide register D. Register D, as I explained, it's B and A, right? So here, I'm going to get the number. I'm going to put the number here, whatever the number is. And then I'm going to put 0 in A, right? And then I'm going to put 10 in X. As you see here, I put 10 in X. So that here, I'm going to divide G by X, okay, which is 10. And now, the quotient is going to go to X, and the remainder is going to go to D. Right? So now I have 2 digits. I have to store one. I have to store them in here. I have to store them here, and that's easy part I did here. So what I did here, I'm gonna say store. Now here I'm gonna store the remainder. Here this one. So here I'm gonna store the register. Here the remainder is actually in register D, but actually, as you know, this remainder should be actually it should be also register D is a word, but actually it should be stored only in the first byte, because it is less than 255 for sure. Okay, That's why what I did here, I just got register B and I just ignored A because A should be 0, right? Because the remainder is less than 10, 9 or less. Okay. So anyway, so I take this one and store it in digits, in the memory location digits. Okay. And then now for register X, I want to repeat the same thing, but for register X, but register X again, I want to just take the first byte. So register X does not allow me to take only the first byte or second byte. So what I'm going to do, I'm going to move register X to register G, and then I'm going to get B, right? Because this is the number I need. So that's what I did. So here I exchange G and X, right? And then I'm going to get B, and then I'm going to store it in the location digits plus 1. You got what I'm saying, guys? Because this is like an array. This array should have 2 locations, right? The first location is digits, right? So next one should be digits plus 1 as address. Okay. So now I stored one number here and one number here. Is that okay, guys? So let me tell you again the conclusion. The conclusion is every time there is an IRQ interrupt, guys, number one, we are going to increment a binary number. I have to make sure this binary number cannot be 100. Once it is 99, after that I have to clear, right? And now after that I have to convert this number from binary to decimal by dividing by 10. Okay, so for example, if it is 17, for example, I have to divide by 10, and then I have to get 2 digits, 1 and 7, and then I have to store them in the array called digits, right? And that's what I did. I divided by 10. I got the first number here. I stored it in digit. I got the, and then I got the second number. I store it in digits. So every time there is an IRQ interrupted, so these 2 digits are going to be updated. So if you look at these 2 digits, guys, you will see they always like counting like 1 0 1 1 1 2 1 3 1 4 and so on. So every time there is one interrupt, it's counting. Okay, but now you just have decimal numbers. I didn't display them yet on the 7 segment. So who's gonna do that? Rti, right? So Rti is gonna take whatever in digits and display them on the 7 segment. So let me go to Rti. Yes, this is Rti here, guys. In Rti number 1 here, Rti actually has to do 2 things, guys. Listen to me. Number 1, I have 2 7 segment. So in one interrupt, I have to enable this one. Next interrupt, I have to enable this one. Next interrupt here, next interrupt here, and so on. So I have to do this, right? Also, in one interrupt, I'm gonna get digits, right? In next interrupt, I have to get digits plus 1. So 1 digit, 1 digit, 1 digit, 1 digit, and so on, right? Again, how can you do that? I already explained the idea. The idea here, I'm gonna use what I'm calling count, right? So I have here count. This count should take the pattern 0 1 0 1 0 1 and so on 0 1. So in one interrupt, if you add 0 plus the beginning address, I'm gonna get this one, and then I'm gonna send to port P, right? Also 0 plus this one, I'm gonna get the first digit. Once you get the digit, I have to add this digit to this beginning address to get a code and send to port P, right? So I have, and if this pattern is 0 1 0 1 0 1, so actually one time is gonna send this one, next interrupt here, next interrupt here, next interrupt here. Okay. So anyway, so let's see how I made it here, guys. So first of all, you have to for sure write this instruction to clear the flag bit. We always do that. Second, now X is pointing at the first location in display, right? This is this array. This array has code as a 7 segment code, and the second one here is also the second one is register Y should point at the beginning in digits, right? So remember, this one has numbers, from 0 to 9, all the codes, right? So anyway, so let's see how it works, guys. As I told you, I'm gonna get count. I'm gonna add count to Y, right? So now, I count Y plus count. So y plus count should give you, because Y is pointing at digits, right? I told you this digit should have 2 location, right? And count 0 1 0 1 0 1. So one time I add 0 for this one time I add 1 for this one time I add 0 for this one time I add 1 for this one, and so on. Okay. So now I have Y plus, so now I have Y plus count, and Y is the beginning address. So now I have I have the address of the digit I have to display right now, okay, which is in Y. So what I did now, guys, so here I'm gonna copy the digit. This is the digit, okay. For example, 17. So in one interrupt, this one is 1. Next interrupt, this one is 7, right? So now I have the digit, okay, the number, the decimal number, okay. Now I have, as I told you here, I have to convert this number to code. How can you do that? The way I did it, x is pointing at the beginning here. So x plus the digit. That's it, right? So if the digit is 0, I'm gonna get this one. Because x is at the beginning address. If digit is 1, here 2, 3, 4, 5, 6, and that's what I did. So if you see here what I did, now here, look here, guys, a comma x. So I'm gonna read a byte from the location a comma x, and then I'm gonna send it to port P, right? What is a? A is the digit, right? What is x? X is the beginning address of this array, right? Okay, great. Okay. Now, so now I did have what I have to do, right? Because I have to do two things here, guys. Number one, I have to send the code for the digit to port B. This is done. What else I have to do right now? I have to enable one segment, 17 segment. Okay, how can you do that? As you see here, guys, now X is pointing on the array of enable. So let me go back here. I told you, so X is pointing here, right? So in one interrupt, count is 0. So I'm going to add 0 plus X. So I'm going to take this one to port P. Next interrupt, count is 1. So I'm going to add 1 plus X. I'm going to take this one to port P, and so on. That's exactly what I did here. So if you see here, guys, load X, right, with the beginning address of the enable, right, and then near count is A. Then I'm gonna get a byte at the location A comma X, and then send it to port P, right? What is A comma X, guys? This one is X plus A. A is count, as I told you, and X is the beginning address of the display enable, right? Is that okay, guys? So now I almost finished. What is left here? So this part here, guys, this part, I already sent the digit. I already sent a digit to port P, right? This part, I update port P in order to enable 117 segment. So are you done? Almost done. There is a small thing I have to do now. What you have to do, I have to update count for next time, for next interrupt. So now I'm going to increment the count, and then if count doesn't equal to 2, so I'm done. I'm going to leave. But if it is 2, I'm going to clear it. That is why, because of this part of the code, that's why you are going to have the pattern I told you about 0, 1, 0, 1, 0, 1, right? So it's going to be always, this count is going to always this way, and that's what I need, okay? So now, any questions so far? Great. So now I'm gonna choose a video to this program, but before I choose a video here, I want you to think, how can you extend this program? This program is used to only for two displays. Can I extend it for 3 displays? The answer is yes. You know how? I'm gonna 3 or 4. You know how? I'm gonna tell you how. Number 1, look here, guys. Number 1, you have to add here. Now this one is 2 for 2 displays. If there are 3 displays, you have to add 1 more. If there are 4, you have to add 4 more, right? Because 1 interrupt for this one, 1 interrupt for this one, and 1 interrupt here, 1 interrupt here, and then you go back to repeat again. If there are 4, right? Also, because there are 4, so I should have 4 digits here, right? 4 digits, not 2, right? Also, because there are 4, this count, this is important. This count should take the pattern 0, 1, 2, 3, then 0, 1, 2, 3. Why? Because in one interrupt, if you add 0 to the beginning, you are going to get this one. If you add 1, you are going to get this one. If you add 2, you are going to get this one. If you add 3, you are going to get this one, and so on. You get what I'm saying? Same thing for the 4 digits here. You have 4 digits, right? 4 digits. In one interrupt, 0 plus beginning, 1 plus beginning, 2 plus beginning, 3 plus beginning, right? Beginning address. Is that okay, guys? So anyway, it's easy to extend it for sure. So now let me choose a video. What this one name? Counting two. Okay, let's start. Hmm. So videos counting two using IRQ. I think this one. Let me see. So look here, guys. Every time I press a button, every time I press a button, I actually trigger IRQ interrupt so that you can see the number is incremented. See? Yes. If I replace this button with a sensor, right? Infrared sensor, you can count events, whatever these events are. Can you see, guys? Great. Now I want to do very simple. Okay, let me go back here. Okay, so I told you guys. Oops, where are we? We are here. Okay. Yes. No, this is RTI. Okay. Look here, guys. I told you I have another idea for IRQ. Again, I like to teach you different ideas, but you can decide if you are more comfortable to use one idea. I'm okay, totally fine. As I told you, as long as it works, I'm happy, right? So this is, I explained here one idea, right? In this idea, to increment a count, as you see here, guys, to increment a count. So here I made a counter, binary counter, and I had to convert this binary counter to decimal, right? That's what I explained. I have another idea here, other than this one, okay? Again, you can use this one or you can use what I'm going to explain right now. It's up to you. This is the other idea. The other idea here, I'm not going to have a binary counter, right? So what you are going to do, I'm going to tell you what I'm going to do. I already have two bytes. One is called digits, right? And the other one, digits plus one. So I already have 2 bytes, 2 memory location, right? So what I'm going to do right now, every time there is an event, I'm going to increment these bytes, right? But when I increment them, I'm going to increment them so that the format of these bytes are going to be in decimal. So I don't need to convert from binary to decimal. You don't need to convert. Okay? What do you mean exactly? I'm going to tell you what I mean exactly. This is a byte, guys. This byte can take a value from 0 to 255. This also a byte and can take a value from 0 to 255. But I'm not going to allow this to happen. This byte, actually, I'm going to force it to have a value from 0 to 9. And this one should have a value from 0 to 9. Why? Because, yes, it is a byte, but the format, it has to be decimal, okay? So what's going to happen is the following. Look here, guys. In the very beginning, let me clear everything. So now I have 2 digits, right? In the very beginning, I'm going to put 0, 0, right? And then I'm going to increment this one, this byte. Okay, this is 1, 0. So now you can just, you can take this one to this 7 segment, no conversion because it's not binary. I'm using bytes, but the format is decimal, right? So, and then increment this one to 2, increment this one 3, 4. Once this one is 9, right? And now I want to increment, now it is 10, right? It can be 10, right? But now I'm going to check if this one is 10, if this one is 10, so I'm going to force this one to be 0, right? And increment the next one. Did you see how I changed the increment, right? So I'm going to keep it this way, right? Every time this is 9 and you increment now it is 10, right? For sure, once it is 10, I'm going to clear it and increment the next one. Is that okay? Let's see how I made the code here, guys. This is how I made the code. So X is pointing at digits, okay? So I told you digits is 2 locations. So X is pointing here. X plus 1 is pointing on the next one. These are the 2 digits I'm going to increment right now. So see what I did, guys. I'm going to say increment is a byte 0, X. So I'm going to increment the first byte, right? And now I have to check if this one, I'm going to compare it to 10. If it is less than 10, I'm done. Just leave. I'm done, right? So that's exactly what I'm going to do. So I'm going to increment the first byte, right? If this byte is less than 10, I'm done. I'm gonna leave, right? Now, what if it is 10? I'm gonna come this way. If it is 10, so I have to clear this one and I have to increment the other one, 1 comma x. So I have to increment the other pi. But there is a problem here. What if, what if, for example, if it is 99, so you increment this one, so now this one is 10, right? So I'm gonna make it 0 and increment the other one. Now the other one is 10, right? In this case, I'm gonna make it 0. Okay, so now I will need to check if the second one after I incremented it is that 10 or not. That's what I'm doing here. So I'm gonna check the second byte, and then if it is less than 10, just leave. If it is 10, so you have to clear it, right? So I'm gonna clear it. Is that clear idea, guys? So it's just 2 bytes, right? I'm gonna keep the format of these 2 bytes like decimal, right? So they should have after 9, if 19, so it should be 20, right? Okay. Anyway, I'm gonna keep the format this way so that I don't need conversion. Anyway, just a second idea. If you like it, that's fine. If you don't like it, I already explained, you can just increment a binary number, and this binary number can take a value from 0 to 255. But I told you I'm not gonna keep. I'm gonna stop at 99, and then after that I'm gonna divide by 10 to extract the 2 digits. Just the 2 ideas. Any question, guys? Okay. Very interesting. So now I'm going to do also some interesting thing. The next program is going to be similar to this program, right? But what's going to happen is, look here, guys. I want to do, let's see. I want a program to count from 0 to 99, increment the count every 1 second, right? So now this program, I don't want to count events. This is different from this program. In this program, we have IRQ, and we have here in IRQ, we have some pulses somehow, trigger interrupted, and I need to count how many, right? So this is not like that. I want to make like a timer, right? So it's going to be 0. After 1 second, it is 1, like a clock, like a timer, right? So that's what I want to do here. So also, I want to use IRQ to stop or resume counting, right? Stop or resume counting. Okay, let me make it easy. Number 1, how many tasks we have here? How many tasks? Look here, guys, how many tasks? Number 1, we need to increment the count, right? So we need to increment the count. Okay, every 1 second, I have to increment the count by 1. Okay, so who has to do this? This has to be done by Rti, for sure. Rti every 1 second should increment the count, right? This is number 1. Number 2, now what if I want to stop or resume counting, right? How can I do that? I'm gonna do that by enabling or disabling Rti. Enabling or disable Rti. So here IRQ, similar to what we did before, is connected to a push button. Every time I press the push button, you actually trigger IRQ, and IRQ actually is gonna toggle Rti, because who is counting? Who's making the counting? Rti. So if you disable Rti interrupts, no counting, right? That's how it is. So if you need to count, you have to enable Rti. So now you have a push button. Every time I push the push button, counting is gonna stop or resume. Is that okay? So this is the second task. So now I have 2 tasks, right? No, we still have another task. There should be 3 tasks. So what is the third one? The third one is time multiplexing, because now in the previous program, I used Rti to take care of the time multiplexing. Now Rti is busy in something else, right? Rti now is busy in counting. Is that okay? So now I have another task, which is the time multiplexing. But where I can put it? You can put it in the main program. Very interesting. Why it's very interesting? Because maybe this is the first program I'm gonna use the main program. Also, I'm gonna use IRQ. Also, I'm gonna use Rti. Everyone have a different task. Very interesting. Okay, guys? And also, this program is exactly similar to the previous program, but I just shuffle the tasks. What do you mean by shuffle? I'm gonna tell you what I mean. Look here. This one, you increment a counter, right? And you update digits, right? Here, this one is done by IRQ, right? Because I want to count events. Every time there is one event, I'm gonna do it here. What I'm gonna do right now, I'm gonna take this code, I'm gonna put it in RTI. But I'm gonna execute it every 1 second. So RTI, as I explained before, every 8 interrupts, right? So here, this part, I have to execute it every 8 interrupts, so that every 1 second, I'm going to increment a count. Okay, very easy. I either use this idea or use the other idea. Explain this idea here. You can use any one of them, but you have to increment it every 1 second. Okay, so now I'm going to take this code. Very interesting. I'm going to take this code from IRQ. I'm going to put it in RTI, right? Because the increment has to be done by RTI, not by IRQ now, this time, right? This is number one. Number two, this is a time multiplexing, right? This is a time multiplexing. This by time multiplexing, I'm going to move it from here. I'm going to move it to the main program, as you will see right now, right? So this one is going to move to the main program. Now, IRQ is empty, right? Yes. And IRQ, I'm gonna flip every time you press a button. I'm gonna flip the RTI interrupts, enable interrupts. So now let's see the program. So that's what I'm saying. Code or programming wise, this program has nothing new. I just shuffled the tasks. So I took this part, put it in RTI. The program of the RTI, I took it, I put it in the main program, and then I put a new flip the RTI enable in RTI in IRQ. Okay, so let's see how I made it. So again, this is the main program here, guys. I'm not gonna repeat it because this exactly the same code I have just explained right now for RTI, but it is done here, as you see here, guys. So here, in every iteration, so here here every iteration count, you increment the count, you go back, and so on. So in one iteration, count is equal to 0. In another iteration, count is equal to 1. Next iteration, count is equal to 0, and so on, right? So it's exactly the same thing I explained right now, but here in RTI, it was like in one interrupt here, one interrupt here, one interrupt here, one interrupt. Now, one iteration, right? So that's why I'm going to loop back again, right? And in every iteration, I'm going to wait 10 milliseconds because I told you I have to wait for some time, right? Now, let's look at RTI. RTI, this is the same code I used before. No, not this part. I'm going to tell you which part exactly, because, yeah, here, this part, this is the same code I explained before to increment count, right? But I have to add this part, because this part here, guys, I need to count the interrupts, right? So if it is interrupt 1, 2, 3, if it is not 8, just leave, do nothing, because I want to execute this part. I want to execute this part every 8 interrupts. Every 1 second, I want to increment the count. Very interesting. So who's going to update digits? Digits are going to be updated by RTI every 1 second. And then the two memory location digits are going to be read by the main program. The main program are going to read them and display them on the 7th segment to do time multiplexing. Very, very, very interesting. Now, let's look at IRQ. IRQ, all what I have to do on IRQ, guys, just flip the RTI interrupts. Is that okay? Sorry, guys. So, just let me. Okay, guys. So this is IRQ. Here in IRQ, every time you press the button, you actually toggle the bit here. Okay, guys. Any questions? So now let me show you the video before we continue. So it's very interesting. You can see nothing new regarding programming. That's why I'm saying it's interesting. Nothing new. I just shuffle the tasks. Okay, let me close Skype. Okay, I don't know. So anyway, let's see the videos now. Yeah, this one. Look here, guys. It's just counting every 1 second. 33, 34, 35. RTI is working, right? That's why the digit, we change the digits, right? Because RTI is working, right? When I press the button now, I toggle RTI disable, so no counting. When I press again, I enable RTI, so it's counting. Press again, I disable RTI, no counting, and so on. Look how it is very bright, very stable, and very bright because it is done in the, because I use a correct delay. Any question, guys? Any questions? Great. So the last program I have here, this program also very interesting program. I'm gonna teach it, and this, I think this will be the end of this chapter. Great. Okay. So in this program, I wanna make like a program, guys, for controlling traffic light, right? Traffic light. So it's like you have two streets. I just try to I just use the name of the streets here in Cookville, Willow and Spring Street. So you have here intersection, right, between two streets. Okay, I took just this intersection here. Okay, very close from us. So as you know, I want to make a program to take care of the lighting. Okay, so how it works, as you see here, guys, if this street, Willow Street, is green, so other one should be red, right? For 5 seconds, I want to make it this way, right? And then after 5 seconds, I want Willow to be yellow, and the other one is red for 1 second, right? Then I want to make red for 1 second, and then I want to make red green for 5 seconds, red yellow for 1 second, red for 1 second, and then repeat again, right? So this is how it is. This is how the traffic signal is, right? So one street is green, the other one is red. And then after some time, this green should be yellow right here, and then red. And now both of them are red. And then I'm gonna open the traffic for the other street, green, right? Yellow, red, and then repeat again, right? So now I wanna do something like that. So how I can do something like that? Given that I need, it's like you have here states. It's like you have different states. This is state 0, state 1, state 2, state 3, state 4, state 5. After state 5, I have to come back to state 0 again, right? Every state, very interesting program. Every state should continue for different time. So for time, certain time, you can control the time. So that means the system should stay in this state for 5 seconds, right? If you know one street is busier than the other street, I can make this one 10 and I can make this one 5. You can do that, right? Easy. You can change anything here. You can change any time here. So this is the time, how much time the system will stay in this state, right? So now I need, so in order to simulate or the colors here, these colors, I'm going to use port P. I'm going to use the LEDs of port B's, LEDs, right? So here, the first LED is going to be the green for spring, yellow for spring, red for spring. Okay, so the first 3 are for Spring Street. The second 3 LEDs are for Willow Street, and they are green, yellow, red, green, yellow, red. Okay, that means, look here, guys. If I'm in state 0, so this one has to be 1, right? I'm sorry, no, yeah, this one has to be 1, and this one has to be 1. So the number I have to output to port B is 00100, and then for sure you put some zeros here, right? This is the number. So what I did, same thing I can do here, same thing I can do here, okay? So what I did, I created an array, as you see here, guys. So this is, as I told you, green, let me, something is wrong here, no. Green, yellow, red, green, yellow, red, okay? So as you see here, guys, if I'm in state 0, this is state 0. I just created array. This array should have the values I have to output to port B in each state, right? So state 1, state 2, state 3, state 4, state 5, and after 5, I have to come back to 0 again, okay? So here, because in state 0, this street has to be, right, yellow and red, right? So this is, no, sorry, red, right? This one is red and this one is green, right? So it is 0 0 1 0 1 0 0. Okay, and so, and this is for same thing for every other one. Okay, I think that's easy, right? So if, for example, if you look at the last one here, guys, it should be red. For red, I have to put here 1 0, and the one has to be here. So this code, you can find it here at the end here. Is that okay, guys? So now I created an array. This array should have, if I'm in state 0, I'm going to take this value to port B. If I'm in state 1, I'm going to take this value to port B. If I'm in state 2, 3, 4, 5. After 5, I have to come back to 1 again. So that's easy, right? So it's easy to move from it's easy to update the LEDs based on the state, right? All what I have to do, I'm gonna here I call this array LEDs, right? So I'm gonna say LEDs, and then if it is state 7, just 7. Or sorry, there is no 7. I'm sorry. State 3, you can just put 3. 2, just put 2 here. So here I'm gonna put the number of the state, and then the value of this element, right? So this one has to go to port P, right? Yes. So actually, as you see right now, I have to program it this way. Port B should equal LEDs, yes. And then I have to put here the number, right? If it stays 0, so I'm going to take this one to port B. If it is 1, 2, 3, and so on. So this is the easy part. The easy part is how to update the LEDs, right? Based on the state, right? Now the difficult part is how can I keep each state for different time? So how I can come up with this time? So if I'm in this state, I have to continue in this state, right? I have to continue in this state for 5 seconds before I move to the next one, right? You know how I can do that? I'm going to tell you how. Who's going to help you on that? Rti, right? So Rti is going to help me on that, because anything that needs counting or time, Rti. So Rti, if I'm in state 0, Rti it has to wait 5 seconds before it moves to state 1. And if I'm in state 1, Rti has to wait 1 second to move to state 2, and so on, this way. So this should be, Rti should take care of this. How Rti can take care of this? I'm going to tell you how. Look here, guys. First of all, Rti is interrupted every 10.24 millisecond. Is that okay? So in order to make 5 seconds, I want to make 5 seconds. In order to make 5 seconds, that means it should be interrupted 488. So if I'm in state 0, Rti has to count how many interrupts. It has to be, before moving from 0 to 1, Rti has to make sure it should be interrupted for 488 times, right? Same thing if I'm in 1 and moving to 2. So it has to take this value. So what I did, guys, here, I did another array. I call it delay. This array should have 5 elements, like these 5 elements, right? But the difference is every element here has to go to port P. But every element here is going to be used by Rti, okay? So that Rti is going to wait how many interrupts it has to wait before it changes from one state to another, right? Okay. So let's see. So state 0 has to wait this time. State 1 has to wait this time. State 2 has to wait this time, and so on. So if you want to change these times, very easy. Just change this array. Very easy, right? So let me tell you how I made it, okay? So the way I made it, guys, here, I have a variable. I call it ix. This variable can tell you the current state. That means this variable, if this variable should take 0 for if I'm in state 0, then 1, 2, 3, 4 until 5. After 5, it has to come to 0 again, right? So this is the value we're going to use for states, right? So every time this one can tell you the current state, right? Here I just use a constant. This one can tell you the total number of states, which is 6. You may not use it and just use number 6. But anyway, also, I told you guys, Rti has to count how many interrupts before it increments ix. So who has to increment ix? Who should switch from one state to another? Okay, IRQ. But IRQ has to count how many interrupts before it does that, right? So how can we do that, guys? We have a variable here. We call it delay time, this one. So what's happened, I'm going to take this one. If I'm in state 0, I'm going to take this one. I'm going to put it here, right? And then Rti is going to decrement, this one, right? Until this one is 0. Once this one is 0, it's going to increment Ix, right? To move to the next state. So I want to show it to you now. Okay. So this is here Rti. Look how it works, guys. In Rti here, here, if every interrupt, Rti is going to decrement the time, right? So, and we are going to execute only this part only when d time is equal to 0, right? So if I'm in state 0, so Rti, so this number 488 should be stored here, and you decrement it, right? So once this one is 0, right? So I'm going to come here to move to the next state, right? As you see, if this time is equal to 0, so that's what I told you, LEDs on, LEDs IX. This is exactly similar to port B. Port B is equal to LEDs IX, right? So that means you are going to take a value point or the state IX, take it from the array LEDs, put it to port B, right? Also, you need to set the time. So for how long this state. So for example, if Ix is equal to 0, guys, look here. If Ix is equal to 0, right? So that means I'm going to take the first element here. I'm going to send it to port B. This number 1. Number 2, I'm going to take the first element here. I'm going to put it to D time. Here, D time. So that I'm going to come here, so that I'm going to move to the next state when D time, this one becomes 0, right? Because every time here, I'm going to decrement it, right? So anyway, so I'm going to take this one and put it in D time. And now I'm going to increment Ix for next time. So I'm going to increment Ix, right? For sure, if Ix is equal to 6, I have to make it 0, because after 5, it should not be 6. After 5, it should be 0, right? So if I increment it and now 6, it has to be 0. Is that okay, guys? So this is how it works. So it works this way. Very interesting idea. It works this way. I have Ix. Let me go previous slide. Yes. I have Ix. Ix should tell you the current state, right? If Ix equal to 0, so I'm gonna get this one. I'm gonna send it to port B. If or here, and also I'm gonna take this one. I'm gonna send it to D time, right? And D time means, this is a critical point. This is the most important thing. D time means, please execute this part, move to the next state, or execute this part when D time is equal to 0. Okay, that's why here I'm gonna stay 488 interrupts, which is equal to 5 seconds. You got what I'm saying? Also, I'm gonna increment Ix, right? And when I increment Ix, I have to make sure that when I increment Ix, I have to make sure that it after 5, it should be 0. Okay, guys, is that clear here? Yes. So here, every time T time is equal to 0, so now I'm gonna move to the next state. I'm gonna take one value from here, send to port B, and this one value, put it in D time, so that you are gonna come here after D time interrupts. Okay, guys, any question? Is that clear? Let me choose a video. Right? So let's use a video. But let me remember, green, yellow, red, green, yellow, red. Okay, let me remember. So let's see the video here. So here, this street is green. This street is green, right? And this one is red, right? 5 seconds. And now this one is yellow, 1 second, red, right? Now red and green. And this will continue for 5 seconds, right? Green, one is, remember, 3 LEDs for one street, the 3 LEDs for another street. So red, yellow, 1 second, red, right? And then green, red. This should continue for 5 seconds, green, red, right? Very interesting. And now yellow, red, right? Red, right? Now this street is green, right? Red, green, right? 5 second, yellow, and so on. Okay, guys, any questions? Hey, we finished chapter 4. Hey, any questions? Okay. Before I start chapter 5, there is just in chapter 3, I just left a very small thing, but maybe important. Not for this course, but important. Maybe you are going to use it later, or I want to explain it before I go to chapter. It's a very small topic. Yeah, this topic relay. So I want to explain to you what is relay and how we use it. What is the problem? I'm going to explain it. Just very simple. And the programming wise is just very simple. So we have here a relay. So let me tell you what is relay and why we need relay. I'm going to tell you right now. Look here, guys. Imagine okay, look here, guys. I have a microcontroller, right? And now, you know the microcontroller, the maximum output from the microcontroller should be 0 volt or 5 volt, right? 0 or 5 volt DC volt, right? What if I want to control a motor? So you have a motor. This is a motor. This motor is 120, 110 or 120 volt AC. Can I connect it directly this way? How I can control this motor? Turn it on, turn it off. That's what I mean by control. So how can you turn it on and off, right? For sure, I cannot do that. Why you cannot do that? Because a microcontroller cannot give you 120 voltage, right? AC. Only it can give you 0 or 5 volt DC. Not only that, the current we get here from the microcontroller is just a very small current. It it depends for sure. You can check the numbers, but in just amperes, right? So just a small current. So it's not going to be enough to power the motor. You got what I'm saying? So how can we solve this problem, right? I'm going to tell you how. You understand the problem before I continue? Yeah, very easy problem, right? So how I can do it? I'm going to tell you how. Look here, guys. One way to do it, this is a microcontroller, okay? So here, I'm going to connect here what we call a relay, right? Relay. And this relay should be connected to the motor, right? Okay. I'm going to tell you, okay, so how it works, what is the main idea? I'm going to tell you what is the main idea. The main idea is that here there is a coil. You know coil, right? Coil. You know, when this coil is energized, so when you put here 5 volt, you energize the coil here, right? So when you energize the coil, you actually turn the coil into magnet. So it becomes a magnet, right? So, and then there is a switch here, physically switch, right? So there is a switch this way, right? And it has like something like a spring here. This is a spring anyway. So what happens, and this one is connected to one. So here it's connected to 120 volt, right? So connected to 120 volt. So what happens here, and this is here air, just air here, okay? So there is no physical connection between them, right? So the idea is, once you put here 5 volt, you energize the coil. Once you energize the coil, it becomes a magnet. And once it is a magnet, you are going to connect the switch. You are going to pull this one down to connect the switch. So when you connect the switch, now the electricity is going to go this way. And now the motor is going to spin. It's going to rotate. Okay, guys? That's it. Once you put here 5 volt, so this one is not a magnet anymore, and this spring is going to pull it up. So you open the circuit and the motor does not work, does not spin. Is that clear, guys? Very interesting. Why it's very interesting? Because there is no physical or electrical connection between this circuit and this circuit. There is no two different circuits. There is no physical connection, right? It's just air, and you turn the coil into magnet to pull the switch to connect it. Is that okay, guys? Now, great. So this is the main idea of a relay, okay? There are different kinds of relays. Some of them are solid state. Some of them are mechanical relay. So here I'm just talking about the mechanical relays. In the mechanical relays, you when you turn it on and off, you hear some sound tick 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 tick, because this is the sound when you turn it on and off, right? So anyway, it is used this way. Please, for the purpose of this course, don't use 120 voltage at all. It's not allowed for the purpose of this course, right? For safety. But anyway, so one more thing I want to explain here, guys, is I told you we have a microcontroller. I have to control, we connect this one to the coil this way, okay? But actually, even this connection maybe have some problems here, this connection. I'm going to tell you why. Number one, the first problem here is, the coil store energy. So once you turn it on, right? So this coil is going to store some energy. So once you turn it off, so this energy is going to be discharged in the other way. So this may damage the microcontroller, right? So what can we do? Usually what we do, we put a diode this way. This is not microcontrollers, it's more electronics, but just you need to learn it. So usually we put a diode this way. The purpose of this diode is just when you turn off, this one has to charge here instead of discharging in the microcontroller and damage it. So always you can see this if you sit in your capstone or anywhere. We always do this way, guys. We always put the diode this way. You should understand. We put this diode this way so that this capacitor can discharge in this diode instead discharging in the microcontroller and damage the microcontroller. So you should understand this one. Another thing also you should understand, or another problem I want to talk about, guys, here. This is a microcontroller. Sometimes the microcontroller cannot provide enough current. So the current here is not enough to energize the coil. Okay. So this actually problem we always face, and I'm quite sure you will face it in your capstone. So that's why I'm explaining it. Listen to me, guys. Now, assume, for example, I need here 100, just any numbers. I just want to explain the idea. 100 milliamperes, okay? But this one cannot give you more than 10 milliampere. Is that okay? So what can we do? So the current I take from the microcontroller is not enough to energize the coil. What can we do? Okay. In this case, we put a circuit here, guys. This circuit, we call it driver. Sometimes we call it driver, right? It has other names. Buffer. Sometimes we call it a buffer. So what this circuit is doing, this circuit is going to... Okay, let me put it in another one. So here, this is a buffer, guys. So we have V input and we have V output. So this circuit, electronic circuit, actually V output should equal to V input. So that it's going to transfer the same voltage. Okay, that's okay, that's good. Not only that, also this one here is going to take a small current from here, and then it's gonna drive a big current here. Still DC current, a big current. But for sure, this current is not, even if this current is big, still this is DC. It cannot be AC. Also, this current actually it's not enough if you are talking like a big motor. That's why you have also to use a relay in this case, because this current is not going to be enough to energize the big motor. Okay. So anyway, so how this circuit looks like, this is just a transistor. So the way, let me go to the slide to explain to you what I want to explain here. So it's just a transistor. Okay. Yeah, as you see here, guys, I just put a transistor this way, right? And this is what I said, buffer, because in the transistor here, the base current is a small current, and the collector current is a big current. That's exactly what I said. If you have a buzzer, it's going to take a small current from here. It's going to give much bigger current to the here. So base current is small, collector current here in case of using bipolar transistor, it may be 100 times the base current. Okay, so we do this way. So if you look here, guys, how it looks like, it is, as I explained, it has some mechanical. Again, I told you there are another one that is not, it's not mechanical, but it's solid state. But here I'm just, but it's the same idea. Explaining the mechanics, so you can see physical switches here, mechanical switches. You can see the spring I told you about here. Okay. The last thing I want to explain here. Okay. So we have one here, and we have three. You can connect them here. Okay. Another thing I want to explain, we have to just, but also in case you use relays, in case of relays, guys, we have two types of relays. Um, we have one relay. Sorry, we have two types of connection in or switches in the relay. We have what we call normally open, and we have what we call normally closed, right? So when you buy a relay, it's going to be written on the relay, this is normally open and this is normally closed. So what do you mean? This part may be more electronics than microcontroller, but I think it's important to learn because 100% you will need it in your capstone, I guess. Okay. So normally open means normally open, like this is switch from here to here, right? If you look at this here, if you look at here, these two contacts, right? They are normally open. Normally open means if the coil is not energized, right? They are open. Once I energize the coil, so this one is gonna move from here to here, so it's gonna be closed. So normally open means the switch is open if the coil is not energized. So and this is most of the time. So most of the time it's open, right? Normally closed is the other way, as you see here, guys. If you look at this one and this one here, okay? If you take this one as a switch, right? So it's normally closed. That means all the time it is closed. Once you energize the coil, you open the circuit. Is that okay? So now you have two switches, guys. One switch, all the time it is open, and once you energize the coil, you close it. That's what we call normally open. We have another switch. This switch, all the time it is closed. Closed means it's connecting the circuit, and it is once you energize the coil, you disconnect the circuit. Okay. Someone can ask me, so which one I have to use? For sure, it depends on your application. It depends on the application. So you have a circuit. Do you want this circuit to run all the time and just to disconnect it, okay, at a certain times? So normally it is connected. Do you need the application, the circuit to be normal all the time connected, and I'm gonna disconnect it for some times, or it should be the circuit should be open all the time and disconnect and connected in some time. So it's up to the application, right? So I just want to show you where, let me go back here. Yeah, here. Yeah, look here, guys. So this is relay. This is you can connect here, but again, you should not connect 110, 120 voltage. You can connect any other voltage, by the way. So it can be 10 voltage, 20 voltage, any other voltage, right? So here you can see one of them is called normally connect. It's not shown here, but it's written on the board. One of them is said normally open, and one of them is ground or common. So if you take this one with the ground, with the common, so this is, you can create a switch normally connect. If you take this one with this one, you can create another switch that's normally open. Some relays come with more than one switch, right? So maybe it has three normally open, three normally connect, and so on, right? It's widely used. That's why I'm spending some time explaining it. It is more electronics than microcontroller, but it's important anyway. Yes. Okay, guys. So here I just give you a simple, okay, now how can you program it if you want to program here in our board? It's very easy. Just you have one pin, we call it BE2, just one pin. You have to configure this pin is output, that's it. And then if you want to energize the coil, just put 5 volt here. So just one pin, output one in this pin, very easy, right? So if you wanna de-energize the coil, just put 0, okay? That's why you can see here bit set, port E, bin 2, right? So this is if you want to put 1. If you want to put 0, you can just bit clear this way. Any question, guys? Any questions? Are you okay? Okay. So now I'm done with chapter 3 and 4, and now I'm gonna start chapter 5. We have only 1 or 2 minutes, so I'm gonna continue next time. For sure, I'm gonna tell you next week if chapter 5 will be in the final or not. Most probably is not going to be in the final. If it is in the final, I'm going to tell you which program I need exactly. So let me start. Just we still have, we can use one, we have 1 minute, right? 1 minute. So here, guys, so I told you before in the very beginning of this course, what is the difference between microcontroller and microprocessor? I told you microcontroller is a system, right? This is so micro inside the microcontroller, it's a system. So it has microprocessor, it has memory, it has other circuits. It has too many circuits. Some circuit for serial communication, some circuit for analog to digital. It's a system on a chip, right? So now one of the system we have here, we call it time function, time system, timer system, and also pulse width modulation. Okay, so and we have other systems, but here, so there are some circuits here for the timer system and pulse width modulation. Okay, so here it's already 420. So okay, anyway, so I'm gonna give you the good thing. I'm gonna give you the main idea next time and next 2 lectures. Unfortunately, this semester, because we lost we lost 1 week because of the bad weather, but anyway, it should be okay. It should be okay because you will see. I'm gonna give you the main idea of the timer system. I'm gonna record the videos if I'm not able to finish it. Okay, just if you wanna learn it more. But the good thing, it's the idea of the timer system is not different from interrupts, and as explained before. Okay, guys, thanks very much, guys, and see you.